Okay, you're given this function and asked to find out when it's increasing, when it's decreasing, and what is the local minimum value of f. Okay, so here's the original function. Here's the derivative. Derivative of e to the anything is e to the anything, but then you got to apply the chain rule and multiply by 6. Same thing for e to the minus x. Multiply by the derivative of the exponent gives you this minus out front. Now we want to apply the first derivative test to find out when the first derivative equals 0. So here I've set it equal to 0. And I rewrote the e to the minus x as 1 over e to the x. And what we're going to do is multiply every term by e to the x to clear the equation of fractions. So this first term becomes 6e to the 7x. Here, when I multiply by e to the x, these e to the x's cancel out, and e to the x times 0 is still 0. Solve for e to the 7x equals 1/6. Take the natural log of both sides and apply the power rule for logarithms. So 7x equals the natural log of 1/6. So x equals natural log of 1/6 divided by 7. Now note that you could write this as natural log of 6 to the minus 1, because that is what 1/6 is, 6 to the minus 1. Move the minus 1 out front, and you get the answer that's given here, minus the natural log of 6 over 7. Okay, so we're going to put this number right here, this critical number, on the number line. I just rounded it to negative 1/4, and we want to find out what is the sign of the first derivative in each of the subintervals that are created. So over here, let's choose a sample number to the left of negative 1/4, like negative 1. What is the value of the derivative at that value of x? Well, 6e to the minus 6 can be written as 6 over e to the 6. Minus e to the first is minus e. That's clearly less than 0, negative. So that means the original function is decreasing. And to the right of negative 1/4, like 0, the function is positive. So to the right of this critical number, the function is increasing. That means that there's a relative minimum at x equals negative 1/4, because the function went from decreasing to increasing, had a horizontal tangent line at this point. And here's f of x sub 1 evaluated, 1.507 approximately. Here's what's actually happening. Here's the graph of the original function in dark blue. This green dashed line is the graph of the derivative, and the first derivative is equal to 0 here, and that's where the relative minimum occurs, negative 0.256 approximately, or the natural log of 1/6 divided by 7. This is actually the tangent line at a given point on the curve. If you go to Desmos and visit this graph, you can slide this red point around and see different tangent lines. Okay, there you go. Hope that helped. If you have any questions, post a comment.